So shall I start, sir?
Yeah. Rajeshri.
There's no more powerful action than leading by example. A very pleasant evening to all present here for this glorious webinar. I take immense pleasure in welcoming you all to the TED Talk on Sustainable Building Materials conducted by Department of Civil Engineering of Sri Sairam Engineering College. If your actions inspire others to dream more, learn more, do more, and become more, you are a leader. I now invite our beloved HOD, Dr. S. Bhagavati Perumal, to welcome our gathering. Please, sir.
Thank you, my good student, Rajeshri. Most respected chairman and the CEO of this prestigious institution, respected principal, Dr. K. Pottumaran sir, dear faculty members, my most loving, affectionating students of Civil Engineering Department, and the chief guest of today's webinar, Dr. Asha Madam. Good evening to all of you. At the outset, we are very happy this evening to get information about sustainability and the sustainable building material and its usages. Sustainability is the talk of the day. How we can reuse and recycle the materials which are used in civil engineering area, how to minimize the pollutions from such material, and especially in the area of smart cities, the sustainability plays an important role. Sustainability related to IoT, sustainability related to artificial intelligence. Civil engineers are collaborating with electronics and communication, computer science and information technology. And the civil engineering field is entirely taking a chance of changes with the help of computer technology, and sustainability is an important area where the revolutions are taking place related to IoT and the artificial intelligence. This is one area where the civil engineers can concentrate more and they can do many innovative, creative projects in their third year as well as in the final years. Even sustainability related to environmental engineering, like water supply, like sewage disposal. This is all the important areas and the need of the day for the development of the country. To talk about all these importance, the application of sustainability in building materials, sustainability related to the latest development in the field of civil engineering, how sustainability is related to the artificial intelligence and IoT for the need of the smart cities. Today, we have an eminent personality, a knowledgeable resource person, a highly educated resource person, Dr. Asha Madam. Madam graduated engineering in civil engineering and post-graduation in civil engineering and got the PhD in civil engineering from Anna University. And also, Madam is heading the civil engineering department of Jerusalem College of Engineering. Moreover, the additional credit to Madam is because of her innovation, her creativeness, Madam is taking care of the research area and leading the research department, holding the position as the Dean of Research in Jerusalem College of Engineering. Under her excellent leadership, the research department in Jerusalem College of Engineering is marching forward, and the faculty members and the students of Jerusalem College of Engineering is achieving a lot of innovative, creative, research-oriented publications and innovative projects under the excellent leadership of Dr. Asha Madam. We are so fortunate. Sairam Civil Engineering Department is so fortunate to have such a wonderful resource person from Sairam College of Engineering. My good students, after listening the talk of Madam, you please interact with Madam. And in this occasion, I invite Madam, in future, you please visit our institution and see the infrastructural facilities of the Sairam Engineering College. You may wonder by seeing the laboratories and all the conference halls and other facilities what we have. And also, the second year, third year, final year students are excellent students we have in Sairam, like our faculty members, and you can interact with our students and the faculties. I am inviting you physically, you present our institution and enjoy the good atmosphere and the facilities and the hospitality of Sri Sairam Group of Institution. With this good word, I hand over the platform to you, Madam. Thank you. Thanks a lot.
Thank you so much, sir, for a very good introduction about me as well as your prestigious institution. Thanks for giving me this opportunity. So I will start to share my screen.
Yes, ma'am.
Yes, sir. Is my screen visible to all of you?
Yes, madam. Yes, madam.
Yes, thank you. So a very good evening to one and all. So as Sujata madam requested from your department, I'm very happy to deliver this guest lecture. Even though in the online mode, I feel happy in delivering this guest lecture on webinar on sustainable building materials today, which is a very growing hot topic in civil engineering as well as in general. So we will concentrate only of our part as civil engineers. So it is a new topic. Some of you might have known about this. Some might not have known about this. So we'll begin from the definition of the sustainable building materials. So what are sustainable building materials? It is nothing but resource efficient processes such as choosing materials of low embodied energy content using locally provided and renewable energy resources. So in short, if you see, the sustainable building materials are those which will emit less greenhouse gases to the atmosphere. So any material which is saving energy, you can call it as a sustainable building material. So what is sustainability? So sustainability is not just about recycling or the use of carbon-free materials, but it is about the energy used through the processes of sourcing, production, and transport. So when you are producing a material, it not only consumes cost, time, but also energy. So far we will be dealing only about, if you take a building material, we will generally deal it only about its cost and its availability. But now onwards, you should think, what is the energy required to produce that material? There comes the sustainability of the materials. Okay. So next, the very commonly used building material, which is the brick. So we all know brick as a common construction material. So what is the standard size of the brick? Can anyone say? I want you to interact with me. I don't want to be a one-side conversation. What is the standard size of the bricks? All the 3-year students are there, no? Yes? The coordinators, you have all the 3-year students in this session, yes? Am I right?
Yes, ma'am. Yes, ma'am.
Yes.
Somebody,
So
students, please answer more. Standard
kindly
size of the
unmute.
brick.
Kindly unmute and talk to me. It may be right, it may be wrong. Don't worry about the answers. Whatever you know, just, yeah, yes.
Ma'am, 19 by 9 by 9 centimeters, ma'am.
Very good. Very good, very good. May I know your name, ma?
Jessica, ma'am.
Yeah, very good, Jessica.
Thank you,
You are
ma'am.
absolutely right. You're absolutely right. There are so many dimensions in the bricks, but the very commonly used size is 19 by 9 by 9. So the brick which we are using day to day construction activities, whether you can say it as a sustainable material, we will know it now. So what are all the process in the manufacturing of the bricks? So first, the raw material for the brick, that is the clay, is being excavated using a digger. Then it is being sieved using a sieve or a metal grid. Then it is being mixed with the sand and water, and then it is cut using wire or any other equipments. Then it is being kept in the oven for 24 to 48 hours. Then it comes to the kiln, where it is being heated to a temperature of around 1300 degrees centigrade. Okay, then it is being taken to packaging, and finally it is being delivered. So do you think now the brick is a sustainable material? So I told you what is the definition of the sustainability. So anything which consumes zero energy or less energy, it is said to be a sustainable material. Whereas the brick which we are using for years together, for thousands and thousands of years, we are using the bricks in the construction. Can you say it is a sustainable material? Of course, the answer is no. Brick is not at all a sustainable material because it consumes energy, resources, natural resources, that is the clay, and it consumes energy for drying it, for cutting it, and the maximum energy consumption is happening where? It is in the kiln or in the furnace, where it is being kept for around 1300 degrees centigrade. And then again, it takes some energy for packaging and of course for delivery. So definitely brick is not a sustainable material. So these are all some photographs. So here you can see the equipment which is used for cutting the bricks of specific dimensions, and finally it is being put it in the kiln, where a large amount of fuel is being used to heat the bricks to a very high temperature. So you imagine what will be the amount of the fuel, that is the firewood, or you are using, and what is the amount of the temperature it is being created, and what is the amount of gases it is being evolved in the atmosphere. So definitely it's not a sustainable material. So bricks are produced from the extracted earth materials such as clay by firing in a furnace. So energy is needed to heat that furnace. Then if we burn coal to fire the furnace, again it does not look like a sustainable production. Again, coal is not a renewable source. It is getting depleted day by day, and burning creates significant amount of carbon emission, again making it not a sustainable choice. But can we think of a material which creates, which can be done, can we think of a material which can be used to heat the bricks, a renewable energy source? Yes, we can do it. Either we can use an electric furnace or we can use a solar power for heating. Then we can make it sustainable to some extent. Yes, so without going deep into the feasibility, we'll immediately see an opportunity to make this process sustainable. Okay, so either you can use a solar power or you can use an electric power. Even electric power generation is also very tough nowadays. Only way we can make it sustainable is we can use the solar power for heating it. So in that way, you can make it the bricks as a sustainable source. So any material which you are using should be made sustainable by some part, by changing its some component. Okay. So finally, after the not only using a production of the bricks, but after the building which you are constructing it with bricks getting demolished, where do the bricks grow finally? Again, it is being created as a dump to the sites or some other places, land. It is used just thrown out nowadays. So again, it's not a sustainable practice. So those bricks which should be separated from other waste, it should be crushed and reused. Then only it is sustainable. Okay, now I hope all of you have got about some idea about the sustainability of the materials. So a material which should not only be used, but again it should be reused, and the production of the material should consume less energy. Then coming to the another commonest material we are using for construction, that is the cement. So is cement a sustainable material? Again, the answer is no, it's not at all a sustainable material, because there are two main processes in the cement. You all know cement is produced with some raw materials like limestone and clay, which is being burnt to a very high temperature. So again, it results in the carbon dioxide emission to the atmosphere. So according to an article given by Robbie M. Andrew, he says that the first is the chemical reaction involved in producing the main cement component, that is the clinker. That is mainly the calcium carbonate. It is broken down into chemical reaction into its oxides, and carbon dioxide is being emitted. This part of the production of the cement makes it not sustainable, because carbon dioxide is being emitted into the atmosphere, which is not at all advisable. And in the second part, if you see the use of the fuels to generate significant energy needed to the heat. So you may use large amount of fuel to produce a very high temperature in the kiln, which we saw in the bricks also. So anything which involves very high heat energy production, again, it's not sustainable. Okay. So in other words, large amount of the fuel which are consumed generally from the non-renewable sources like a petroleum, coke, or gasoline or natural gas, again, it is being termed as non-sustainable. So, and it emits, of course, carbon dioxide. Okay. So, according to the study, the calcination chemical reaction is responsible for 52% of the carbon dioxide emission. So, any cement production involves the evolution of the carbon dioxide gas into the atmosphere. Out of that, 52% of the carbon dioxide is contributed by this calcination reaction. So, the remaining 48% is contributed by the fossil fuel burning. So an average of, imagine, you think 850 kilograms of carbon dioxide is being generated. So now you can see how dangerous is the production of the cement, how harmful it is. Okay. So now if you see the raw materials, the basic steps in the production of the cement, we have to collect the raw materials, that is the limestone. We have to use the equipment, we have to do excavation or mining, and then take it, the raw materials, carry over to the cement factory, process it, then mix it with clay, then burn it to a very high temperature. Then again, it is being, after the cement is being produced, it is taken to the respective places. So even the transportation of the cement will consume amount of energy. Okay. So this is the overall picture, that is, the cement consumes 33% of electricity in one stage, and 42% in clinker storage and cement grinding, 1% in lighting, and 1% in packing and dispatching, and 25% in raw material grinding, and 25% in clinker burning and grinding, and 5% in quarrying, 5% in coal grinding, whereas 100% in the clinker burning. Again, I told you that it is the place where most of the energy is consumed. So it consumes around 88% of thermal energy and 12% of electrical energy, which is not at all sustainable. Okay. So we are in the need for sustainable building materials. So all the materials, most of the common materials which we saw now, that is the brick and the cement, is not at all sustainable. So likewise, the steel, the concrete which is produced with that cement, and aluminum consume energy and release carbon dioxide during their production process. Therefore, research into the new material production, manufacturing methods, recycling of the building materials. So the materials which once used should not be thrown out. It should be again recycled and used in the construction or any other part accordingly, so that there is low embodied energy of the materials. So techniques and technologies should be improved so that natural resources are used minimally and buildings are constructed. Okay, so this is the need for the sustainable building materials. So hereafter, we should not think it is only the vehicles which emit polluting gases, but also the buildings which we are constructing. They consume around 20 to 50% of the physical resources. And also they emit very high amount of gases into the atmosphere. They are also equally polluting. Okay. So we are using natural resources like wood, minerals, water, and energy. So it is also be a cause for pollution, and because of the emissions, it is being produced. So what are all the questions you should ask for assessing the sustainability of materials? How can you say a material is sustainable? First, you should ask what is its function in its whole lifetime. Does it meet the performance requirement of its application? How widely it is available? So any material, you should first think whether it is being available locally and it in a large quantity. Then only you should use it. Do they regenerate? Can they be produced again? How quickly they can be produced? So what is the process to make it in a usable form? What are the environmental impacts? What, if you are processing it to bring it to a usable form, or is it causing any harm to the environment? You should think about that. How much energy and water does it take for its production? How much waste material does it generate? What does it need to operate? Any inputs, maintenance inputs, or operating energy, or people involved in producing, delivering, and installing? Then that they also consume, they are also a part of energy consumption. How long, finally, how long the product will last, and what will happen at the end of its service life? So these are all the questions you should ask for yourself when you are assessing the sustainability of materials. So the 6 principles of sustainable buildings, we will leave about the sustainability general. We'll come to the buildings because we are all civil engineers. We should think about that point of view. So we should try to optimize the site potential. We should optimize the energy use. So site potential means like you should be maximum using the site on which you are constructing the building. So suppose if you take a slopy ground, the slope of the ground, the landscaping of the building should be done in such a way that the storm water is not being wasted. So you should make use of the site optimally. And energy use, what is the amount of energy you are spending in constructing the building? How much water you are using? It's a pure water you are wasting for construction, or you are using recycled water. And optimizing the building space and material use. So the building should be constructed in such a way that no single space or no single room of the building is being wasted without any use. And enhance the indoor environment quality. Indoor environment quality plays a major role in the sustainable buildings. That is the lighting, the ventilation, etc., etc. All should be considered while designing a sustainable building. And optimize the operational and maintenance practices. Okay, so coming to some sustainable buildings. So what else can be used as a sustainable building? Much research is now going on in the area of bamboo. So bamboo, why they are choosing it as a sustainable material? Because the first reason is it has a high self-generation rate. That is, it can grow up to 3 feet within 24 hours. Imagine, while you are cutting the bamboo trees on one day, the next day you will get the same bamboo trees very fastly. So it is said to be a viable alternative for sustainability. It continues spreading and growing without taking extra care for harvesting. And it is a perennial grass. The another thing is availability. Luckily, in our country, it is being available, except in Europe and Antarctica. This is a grass, which it's not a wood, it's a grass type, which grows on every continent. What are the benefits of the material? As a civil engineers, we should think about it. It should not be heavy. It should have strength. It should have durability, etc., etc. So it satisfies all these requirements. That is, it has high strength to weight ratio. You have to spend minimum weight, but the strength will be very high. And even greater comprehensive strength than concrete and the brick, and lasts incredibly long. So it is the best choice for flooring and cabinetry. Not only for flooring, nowadays they are even constructing towers, transmission towers using bamboos. Unfortunately, but bamboo requires treatment. There will be some benefits and disadvantages. The disadvantage of this is like it should be treated properly for resisting the insects and rotting. So if left untreated, it contains a starch that greatly invites the insects. Okay, so we should take care of that. So this is the photograph which shows the bamboo pieces, and this you can see a very good structure which is being built entirely with the bamboo. So nowadays many structures, bamboo has been in construction for a very long time. So even in the thousands and before ancient time itself, people were using bamboo as a reinforcing material. It's not a new one for construction, but now after the sustainable practices have come into picture, this has been highlighted very much. So the next type of material you can use is the papercrete and the hempcrete. So what is papercrete? The concrete with the two building materials, that is waste paper and the hemp. It is being used. So it is the waste paper is being used, and the hemp is also being used as aggregates, and it is mixed with the cement or clay instead of the non-renewable aggregates found in the traditional concrete. The waste paper, the hemp, these are all renewable. It is being generated in large quantities. You can use this as a material. The repulped paper fiber, hemp, and even bits of wood or sawdust has been used to create concrete-like materials for building. Even if interior walls of new buildings were replaced with this alternative sustainable building material, the environmental impact would be amazing. So any waste material which is being put into your structural element, definitely it will reduce the environmental impact. But at the same time, you should see whether it satisfies the function for which it is being used. Okay, so these are all the photographs of the papercrete blocks and the hempcrete blocks. The blocks are being using these waste materials. Okay, so what are the advantages and disadvantages? Any material which you are putting into practice will definitely have some disadvantages also. So the disadvantages of this papercrete and hempcrete is the poor moisture resistance. So moisture will readily ingress into these materials without taking much time. But on the other hand, if you see, the heat and sound insulation is to be excellent than the traditional concrete. And the papercrete has higher compressive strength, and it is also lightweight, and it is the best for roofing. Okay, and coming to the third material, that is biocomposites. You can see the mushrooms. So mushrooms we eat as a food, but have you imagined these mushrooms can also be used in construction? Even I was surprised to see this. So the mushroom roots, otherwise it is also called as mycelium. They can also be used for making building materials that are stronger than concrete, more insulated than fiberglass, and completely compostable. So there is a company called Ecovative. So it is one of the first companies in the world which is growing mycelium for building applications. So it's not here, it's somewhere in abroad, and it has a few products already in its works. So they are producing mushroom particle boards. So one of the most notable and eco-friendly insulation material, it is injected between the interior and the exterior walls. So the insulation effect is very better than the fiberglass which are conventionally used for buildings. Okay. So this is the photograph of the mycelium, and the right side you can see the Ecovative company product particle boards with the mycelium. So the sustainability grows like this. So you should think or imagine of materials like this, which can be grown and it can be converted into a building product. The next one is the straw bales. So straw is also not new for construction. Ancient times it has been used for reinforcing purpose because it gives better tensile strength to the material. So it has been used in the past as a way to reduce mud and erosion while finishing a project in the wet climates. So straw walls are also made by sticking bales between the structure beams and then plating it on both sides, which makes the walls airtight. Another important thing is it is as important as the moisture in the walls could cause all organic materials or biodegradable materials which we are using. Definitely they have less moisture resistance and it will be easily attacked by the insects or by rot. So we should take care for it. So benefits of the straw bales in construction include low cost when sourced locally and their incredible insulation abilities. And it is also to be found more flame resistant than regular wood frame buildings. So here the wood frame buildings are not commonly used, but in Western countries they are using wood frame buildings. So the straw bales are found to be more effective for those structures. Okay. So this is a building where you can see the bales are being used for the construction of the walls. And here also they are using, the walls are being constructed with the bales, straw bales. And next material which can be used for buildings apart from the conventional material is the rammed earth. Rammed earth is not a new material, but it has been used in human civilization for thousands of years, and for the surprise, if you see, it lasts for a long time. It's a popular and affordable solution for creating steadfast foundations, floors, and walls through natural materials such as chalk, earth, gravel, or lime, and then compacting them. Even now, you can see many historical structures which are being built with rammed earth or standing in a very good condition. So what you have to do, you have to press the ram tightly in the wooden forms so that it creates a wall that have a similar feel to the concrete. Buildings made from rammed earth are made safer or fortified. Fortified means reinforced by the use of rebar or bamboo. So when you're using rammed earth, it should be reinforced by the use of steel or bamboo for additional strength. You can use mechanical tamper, which will greatly reduce the amount of labor required. When you are using this type of soil materials like clay or rammed earth, it requires much of compaction. Then only it will gain the required strength. So you can use rammed earth walls and floors as for thermal storage, allowing the sun to warm them in the day, and they will slowly release the warmth in the cooler evenings. This is what is required in the tropical climates like India. So they should absorb the warmth, and if the climate is very cold in the evening, they should release the warmthness so that the indoor temperature is extremely good. So here you can see a picture of the rammed earth wall. Okay. So what are the major ingredients of the rammed earth? What does the rammed earth consist of? It consists of the subsoil that has suitable proportions of sand, gravel, and clay, and a stabilizer. Okay, we should not live only with the soil materials used, but we should add a stabilizer. Okay, either you can use a lime. Ancient times they were using lime or even animal blood. So nowadays it is not being practiced, but you should use some stabilizer. You can even use chemical stabilizers. So how the rammed earth walls are constructed? The soil mix is poured into the formwork with a depth of 10 to 25 centimeters, that is 4 inches to 10 inches, and then it is compacted so that it becomes only 50% of its original volume. Okay, but it requires much labor. Tamping was historically manual with a pole, but now machineries have been developed. So you can use pneumatically powered tampers for compacting the ram. After the wall is complete, then it is sufficiently strong to remove the formwork. Then it can be surface structure can be improved by wire brushing or carving, etc. The compressive strength of the rammed earth increases as it cures. So the cement, even you can use cement for the stabilizing of rammed earth, is cured for a minimum period of 28 days. Okay. So what are all the environmental effects and sustainability of the rammed earth? So rammed earth is probably the least environmentally detrimental construction material. It does not cause any harm to the environment. So rammed earth has potentially low manufacturing impact contingent on the amount of cement and the amount that is locally sourced. So it is often requires quarried aggregates rather than the earth. So the edifices of the rammed earth are more sustainable and environmental friendly than other building techniques which use cement and other chemicals. So what do you mean by edifice? The buildings which are made up of the rammed earth are more sustainable and environmental friendly because they are not destroying any non-renewable resources. Because rammed earth edifices use locally available materials, they have low embodied energy. You don't require much processing for using the rammed earth like heating, etc. So the embodied energy used also is very, very less. The soils which are used are usually typically subsoil, which conserve the topsoil for the agriculture. And the formwork is removable and it can be reused, reducing the need for the lumber. Okay. So rammed earth can contribute to the overall energy efficiency of the edifices. That is the density, thickness, and thermal conductivity of the rammed earth makes very suitable for passive solar heating. Okay. So this is about rammed earth. It reduces the greenhouse gas emissions. Transportation, if you procure it locally, it will be very cheap. And the production of cement can be brought down. Okay. So this is about the rammed earth. You can see the picture here of a watchtower which is being constructed in China in 202 BCE. Still it is being in this condition. So you can imagine the structure's durability. It's standing for a very long time. And this is another structure which is Holy Cross Episcopal Church in South Carolina, which is being erected between 1850 to 1852. It was constructed in between 1850s. So still the structure is being in a very good condition. It's around 200 years back. But if you see the structures which has been built recently with the cement and concrete, it is getting damaged very easily. So in the life of a normal structure, which is being now constructed with reinforced concrete, it is around only 25 to 30 years, or maximum 35 years maximum. Thereafter, you get many repairs. But see, the rammed earth structure, it is being in a very good condition. So the principle of the sustainability is shown in this picture. Like, you have to minimize the use of the resources, you have to reuse the resources, you have to recycle the available resources, and then energy should be minimum, and the disposal, after disposal also, it should be reused. So the reduce, reuse, and then recycle. The 3 R's are the principles of the sustainability. And coming to the next one, this is recycle the plastics, because we are using plastics in a very large amounts now. So what are the types of plastics which we generally use now? Can anyone list the types of plastics? What are the types of plastics? So I want all of you to interact, because I keep on saying, I want you also to interact with me. What are the types of plastics, students? Any idea? Polyethylene, PET, PVC. Have you all heard about this? Yes? Okay. Are you all listening at least? Yes? Yes? At least say
Yes,
yes,
ma'am.
students.
Yes,
Yeah.
ma'am.
Thank you. Thank you. Thank you. So the plastics which we are using nowadays is also of various types. And it is being generated in huge quantities in the last 20 to 30 years. Before that, plastics was not in consumption for a large quantity, but nowadays it is being enormously used, and enormously it is being wasted, and it is being thrown everywhere. So the recycled plastics also contribute for sustainable environment. So what is meant by recycled plastics? The plastics which is being once used for some purpose and then it is being thrown out can be used. So it helps in save energy and landfill space. So recycled plastic can be used in the new building and construction applications every day. It reduces the cost without sacrificing the performance. So it can be blended with the virgin plastic. Virgin plastic means the new one which is being produced. So where all the plastics can be used? Now a lot of research has been carried out where we use plastics for all applications like cement replacement, aggregate replacement, etc., etc. So I will not go into all, but I will talk about only few things now. So the plastics waste can be used as a replacement for aggregates. Recently, a professor, chemistry professor, you would have heard, like he had done a project on the roads also. He has used. So in the similar way, the plastic waste can be used for sub-base construction of the pavements, which proved having improved shear and stiffness and bearing capacity. It is being done by Chowdhury, and many researchers have done research, have carried out works with waste plastics. You can Google it and you can find out from the internet. And even it can be used even as a wood replacement because it behaves similar with the wood. It can be cut, sawn, and nailed. Anything we can do, whatever we are doing with the wood, it can be done with the plastics. So, in addition to the wood-like behavior, they are also more durable than the wood in terms of weather, biological, and salt water resistance. So, however, the high cost associated, whenever we are talking about the recycling, again, it involves some process and again, it's expensive. So, however, the types of waste plastics can be used as a fences, boat docks, benches, etc., railroad ties. It can be even used for door panels. You can use recycled plastic waste as a door panel by combining plastic waste in pellets or powder form with a cellulose fiber. Again, it is a sustainable practice. And coming to next one, the PVC windows. So in all the new construction of the buildings nowadays, you cannot see the timber windows, but we can see only the PVC windows, UPVC windows. Have grown popularity nowadays. So in those windows, we can use this recycled plastics. The frames are 100% recyclable. It has long life up to 40 years. And we have a lot of plastics and it has the same insulation quality as the regular plastic. So PVC windows have reached to the high level of market production. They are impressive with perfect design. You can mold it to any shape, and you can give it any color, and you can mold it in whatever shape you want, and they are 100% recyclable. So this is the photograph which is of the recycling plant, which can use for recycling of the waste plastics windows. So recycling of PVC for windows, there is a company called Schueco. This company, it allows the old PVC to be recycled to 7 times. Okay, so it can be only a few centuries before the PVC is finally no longer fit for purpose. So you can recycle it, recycle it, recycle it. You can do it for 7 times and it can be again used. So PVC recycling therefore prevent huge amounts of carbon dioxide emission by producing only a 1/10 of the environmental harmful gas required to new PVC. Here we are talking about the recycling of the PVC in the windows. So instead of using a fresh PVC for the manufacturing of windows, if you are using recycled PVC, it reduces the huge amount of carbon dioxide which is being emitted into the atmosphere. So here you can see the UPVC doors and windows. So you can see in European manufacture of PVC window profiles, they used 363,000 tons of recycled material, which is saved 726,000 emission of tons of carbon dioxide. So one of the old PVC windows have arrived at the recycling plant. How do you recycle it? You are first shredding into different components, that is metal, rubber, and glass. And then the PVC is melted down to remove any foreign particles. The PVC granules are then pressed to form the core of a new window profile. Okay, so these are all the waste UPVC window parts which are being subjected to recycling. This is taken from Google site. Everything I have taken from the internet only. You can very well find this information. So it is taken from Blueplanet Recycling company. So what in the Schueco company I mentioned just before, what they are doing, they are recycling the PVC, old PVC, and they are shredding into granules like this, and then they are heating it again using for the production of the UPVC windows. So these are all the informations which are now going on research. Okay. 10 years back itself, I tried with students like you the production of concrete with electronic waste. So here you can see the picture of the powder-like material. So this powder-like material I have taken from the printed circuit board of the computers, which are being discarded in large quantities. Yes, printed PCB. So that is being crushed into powder, and we made our students. They energetically worked like you, and they cast specimens to test the efficiency of this. So we cast beams, cylinders, cubes, etc. So we used the printed circuit boards to the extent of 10%, 20%, and 30%. But as expected, the strength was decreasing since the plastic waste is not having that much strength. So this is a research. We just tried with it and we found that use of the plastic waste definitely reduces the strength of the materials. Okay, it is not increasing the strength as expected, but it's decreasing the strength. Even if you see the split tensile strength, yeah, when the control mix, it is having 3.36, whereas 10%, 20%, and 30% of the electronic waste intrusion, including in the concrete, reduces the strength values. Okay, so anyway, it's a research. So like this, I request all of you to do some research works, but not with the reduction of the strength, but we have to try to implement with the strength balance with the conventional concrete, or at least in par with the conventional concrete. Okay. So even you can see this research as an example. Okay. I want to show this photograph. This is a person who is owning a company called Replast. He has cast replast blocks made up of fully recycled plastics. All these blocks are being constructed with fully recycled plastics. Okay. So I want to introduce another term which is related with sustainability, which is called as the embodied energy. Embodied energy is the energy associated with each stage of the material, that is for extracting the material, processing, manufacturing, transportation, and distribution, and assembly and construction. So in each stage, we are consuming some energy. So that energy should be reduced if you want to build a sustainable structure. So embodied energy concept can be used to evaluate the sustainability of the materials. It is significantly influenced by the construction materials used. So whenever you are constructing a building, you should take care that you are reducing the energy in its extraction, transportation, mixing, and the actual construction phase. Okay, so then only you are producing a sustainable structure. So durable materials which last longer and reduce the overall embodied energy makes a structure sustainable. So recycled materials also have low embodied energy. Why do they say this? Because when you are freshly producing a material, you require much amount of energy. But when you are using a recycled material, you are definitely reducing the energy consumption for its manufacturing stage. So definitely it will be sustainable. For example, if you are producing polypropylene, yes? Any doubts? So production of the polypropylene fibers from the virgin plastics, fresh plastics, it requires extraction of crude oil, coal or natural gas, and production and processing in the refineries, polymerization and production of pellets and granules. See how many processes are there. And associated with each process, you have some amount of energy consumption. Whereas when you use a plastic which is being already produced, you are breaking it and using it, or you are crushing it and using it, definitely you reduce some part of energy. Okay. So energy required to produce recycled polypropylenes is much lesser to the energy required for extraction and processing of a fresh plastics. Okay, this graph, you can see what is the amount of energy consumption for each building material in terms of megajoules per kilogram. So for producing 1 kilogram of some product, how much megajoules of energy has been spent. So the values keep on increasing from concrete, cement, bricks, timber, glass, stainless steel, polypropylene, polyethylene terephthalate, PET, and commercial aluminum and primary aluminum. So aluminum consumes much amount of energy. So this is you can see the construction site waste material which is being dumped. So even you should think of using this waste material, construction waste material, into your actual process. Much research has also been done in this area. So you have to find out what is being done, what is yet to be done, so that you can develop a more sustainable structure. So now I'll ask a small question. When we say that embodied energy of concrete is 1.9 megajoules per kilogram and the embodied energy of plastic is 90 megajoules per kilogram, what does it mean? Can anyone answer for this question? Kindly unmute. So what does mean by, I explained you what is meant by embodied energy. I told you what does embodied energy mean. Now they are saying for concrete it is 1.9 and for plastic it is 90. So which is consuming more energy? Anyone please?
Students, you can unmute and interact with madam, please.
It can be wrong. Don't worry about the answers. Please unmute and answer. So which is more?
Shall I call the name of the students? Please answer. Okay. Whether it is right or wrong, madam won't mind anything. You just interact with madam.
Okay. So this means that all processes result in the production of 1 kilogram of concrete has used 1 megajoules and 90 megajoules. So the concrete is definitely taking less energy than the plastic. Okay. So materials with a lower embodied energy put less load on the environment. Always we should think of the materials which are producing, which are consuming less energy in its production. So I'll come to the next question. What is the expansion of lead? So this is also associated with the sustainability. That's why I'm asking this question. So what is the full form for lead? Anyone? Have you heard this term before?
Yes, ma'am.
Yes.
Lead is in a grade given for green constructions, ma'am.
Yeah, very very good, very good. Who is this?
Yes, ma'am, like they categorize the construction things. I guess it is something related to energy and environmental design, ma'am.
Very good, very good. May I know your name?
I'm Karthik Ram, ma'am.
Karthik Ram. Very good, Karthik Ram. You are absolutely right. It is something related with the rating of buildings for their energy released or energy consumed. Okay. So lead is nothing but leadership in energy and environmental design. This is an organization which grades the buildings, whether it is consuming less energy or more energy, whether the building is a green building or not. Okay. Coming to the last question, LEED deals with the sustainable aspects of agriculture, chemical industry, buildings, or motor vehicle. What does LEED deal with?
Buildings, ma'am.
Very good. So I'm not concentrating about the chemical industries or motor vehicles. Even all the other components, everything is associated with the LEED rating. But we will concentrate as a civil engineers. Only I can't talk about the buildings. Even when you are getting a fridge, when you are getting a TV, when you are getting an AC, they are marketing it as 5-star rating, 4-star rating, 3-star rating. All what are these about? They are all associated with the energy consumption of that product. So as a civil engineers, we should think of a building which is consuming less energy with the least available resources. So in future, I can expect some of you doing research in this area. I hope these are all the references. I hope my lecture today would have enlightened you about some points about the sustainability. So this is another photograph which is using solar power to recharge this vehicle. So this is one point of sustainable approach in the case of vehicles. Now e-vehicles also are becoming very popular. So thank you. I want to know any questions are there regarding this.
Thank you very much. Thank you very much, Asha Madam, for your inspiring presentation. Really, our faculty members and the students enjoyed a lot, getting a lot of information about sustainability. You started with the manufacturing materials from low energy content using locally provided and renewable energy resources. And then you presented about the extraction of the raw materials which we are using for the manufacturing of cement and the types of the cement. And the very valuable thing which you have highlighted is the 6 principle of sustainable buildings. Like, if I remember right, optimization site potential, optimize energy use, product and conserve water, optimize building space and material use, enhance indoor environmental quality, optimize operation and maintenance practices. And the examples which you have highlighted, the bamboo, plastics, and all of the things. Of course, I usually insist our students to do the project work in the pre-final year and as well as in the final year to take the fiber materials related to bamboo and other related things to find out the strength. And you have rightly pointed out, when you test the quality of the concrete, if the strength is less, or if the strength is more, you do the experiment and find out the things. That is the good approach which you have highlighted, madam. Anyhow,
yes.
The most lovable concept in your presentation is the questions which you have included at the last.
Yes, I always knew this because then only
that is a very good approach. That is a very good approach, because how far the students understand your presentation. Finally, some simple questions you put up and you interacted with the students, whether that will tempt the students to open their mouth and interact with the guests.
Yes, that only I am putting that question.
That is a very good approach. I advise my faculty member, when you are giving presentation, please follow what Dr. Asha Madam did today. At the end, you give some objective type of questions and display in the screen and make the students to think and answer. At least at the end, if they open their mouth, we, the resource persons, will be happy that whenever what we presented, they understood and they interacted with us. Otherwise, when you open the platform for question answer, nobody will open their mouth and ask, even including the faculty members. I salute your approach, what you have done it at the last, putting the questions and making the students to answer. Very, very excellent presentation. We do expect your physical presence in Sairam Engineering College, madam. We invite you very soon. Please accept our invitation.
Sure, sir. Thank you so much.
Thank you for your valuable time. Thank you.
Thank you, ma'am. Thank you, ma'am. Thank you for your excellent presentation, and it was very useful to us and our students also. Thank you very much, ma'am, for your valuable time also. Okay, thank you, ma'am.
Thank you.
Thank you, ma'am. It was very informative and knowledgeable. I know most of us would have gotten a clear insight on sustainable building materials. Gratitude is the healthiest of all emotions. The more you express gratitude for what you have, the more likely you will have even more to express gratitude for. And to express our form of gratitude, I invite Jessica to propose the vote of thanks.
Thank you, Rajashri. A very good evening to one and all present here. I, Jessica James, on behalf of the Civil Engineering Department of Sri Sairam Engineering College, express my heartfelt gratitude to everyone who made this webinar a grand success. First of all, I would like to thank our CEO, Sri Sai Prakash Liyamuthu, Principal Dr. K. Pokumaran, and our dynamic HOD, Dr. S. Bhagwati Permal, as well as the coordinator of this webinar, Mrs. A. Sujata, for giving us and providing us the platform to gain and cultivate apprehensions. I would also like to extend my gratitude to our guest of honor, Dr. P. Asha, for spending her valuable time with us and enlightening us with knowledge on sustainable building materials. At last, I would like to thank all the participants as well as faculty members for their kind cooperation throughout this webinar. Thank you all and have a great evening. And ma'am, Dr. Asha ma'am, we await your physical presence, ma'am.
Sure.
Thank you, ma'am. Have a nice evening.
Thank you. I thank all the faculty members, HOD, and the management of Sairam Engineering College, and not the least the students who have been interacting with me when I ask the questions. Thank you so much, and I encourage you to do more projects in this area. Then only my lecture will get fulfilled. Thank you so much for inviting me.
Thank you, ma'am. Thank you.
Thank you, ma'am. Shall I leave?
Yes, ma'am. Yes, ma'am. Sure. Thank you.
Thank you.